Hi, sir.
Hi, Amy. How are you doing?
I'm good. How are you?
Good, good. So, how
Nice.
do you find calculus now? We are midway through.
Actually, all right. Yeah,
That's good.
just trying to still do the work for my book and things.
Okay.
And yeah, just trying to.
So, could you do some questions from your book?
Yeah, some of them. But I'm mostly doing your videos and those questions.
Okay.
And until I get like the whole thing, then I'll
Okay.
start my book because my book's a bit weird. It
Okay.
starts with the stuff that you said that you would introduce later. It did it in
Okay.
the beginning and things. So yeah.
Okay. So, actually, now it's good time for you to start from your book.
Okay.
Also, share with me the questions which you have and where you are having any difficulty, so that from now onwards, since you have a very good foundation, we should know what should be covered next, what is not yet covered, right?
Yeah.
So till now, what we have done is we have understood what are limits. We have understood how to find derivatives using the power rule, the product rule, the quotient rule, right? We
Hmm.
also introduced to you the concept of power rule combined with the chain rule, right? So we said a modified or extended power rule. But today, extensively, we'll talk about chain rule. So most of the time when you work, you have more than one function to work with, and you know functions are related. So value of one function depends on the other, and both can work together. You may get third result. That's what in real life is.
Mm.
And so the chain rule, which we'll talk about today, will really help us to find the derivatives and understand these functions better. Okay.
Okay.
So good, you have some idea at least, so it'll be easy for me to explain the concepts. Let me share the screen with you. This is about the chain rule. Can you see the screen, please?
Yeah.
Perfect. So when we talk about chain rule, first we have to discuss what is composition of functions, right? Because
Mhm.
chain rule is only applied when there are more than two functions. Now, composite functions, I think you've done earlier. Have you done composite functions earlier, Emmy?
Yeah.
That's good. So basically, in composite functions, we could provide input to one function, and the output of that goes into the input of the other function, right? As shown here in the diagram. So we have an input x, which goes into one function, g. Output is called g of x, right? Now this output g of x becomes input to the function f, and the output which you get is f of g of x, right? Because g of x was now the input. So this is what we call kind of composite function. Now from here, many things are very clear, and that is the domain basically depends on the domain of g. So the domain of your composite function subset of the domain of G, right?
All right.
So only those values of G will qualify which can be the domain of F. For example, if I have a square root function in F, then we can only have inputs which are greater than or equal to 0. So therefore, if I have a quadratic function as G, quadratic function could give me negative and positive values also, x squared minus 4, for example, right?
Hmm.
But those values which are negative cannot be the input for the function f, and therefore the domain of G will be restricted, correct?
Yeah.
So we say the domain of the composite function will always be subset of the domain of G, correct?
All right. Okay.
As far as the range is concerned, the range will be also subset of function f, because f may not get all the elements in its domain, right? And therefore, its range will be at the most equal to range of f or subset of those values. Is that clear to you?
Yeah.
Now, we'll take up this composite functions, and once we have these composite functions, then we'll apply the chain rule to find the derivatives, that is gradients. And we have already seen what is power rule combination with chain rule, but we'll take some questions to practice, and then we'll take some other examples and exam practice test. Okay?
Okay. Yeah.
Begin with the composite functions. So once again, the same diagram for you. So this time, I've already explained you the whole concept. Amy, can you read this for me? What is a composite function?
The composition of a function f of x with g of x can be written as, is
F
that,
of g. Now this
oh,
circle in between is the operator, is the composition operator, right? Just
all
as
right.
the plus, minus. So when you see g of f of g, of, we read it as of. So which is also written as f of g of x. Now that indicates that g is a function of x and f is a function of g of x, right? So
Um,
both are functions of x. So they can both be differentiated with respect to x. Is that clear to you?
yeah.
So this letter in between is an operator for composition. So f is composed of g. So we say
All
f
right.
of g. Yeah, read further, please.
Here, f of x is the outside function and g of x is the inside function,
Correct.
also called the argument.
Especially when we talk about trigonometric functions, we say sine theta. So theta we say argument, right? So
Mhm.
that is your inside function or an argument. So we use both these words, inside function or argument. Okay.
All
Now,
right.
yeah, further.
In this case, the output of g of x becomes the input of f of x.
Correct. So output of g of x becomes the input of f of x, right? And that is your composite function, which is the net output, right? Now here is an example for you. We are writing capital F for composite function, and this capital F of x is composed of two functions. One inside function is x squared minus 4, right? Which
Mhm.
later we are writing as u equals to g of x. Inside function is x squared minus 4, okay? The outside function is square root. So we are writing now a different function u, which is the outside function now f of u, which is square root of u. So
Oh,
whatever was inside, square root of that is capital F of x. Is it okay?
yeah.
So capital F of x is a composite function which could be written as f of g of x. We know now that g of x is x squared minus 4. So I could write this as f of x squared minus 4, right? Now,
Mhm.
f is defined as square root of u, correct? So whatever is here, argument is here, we'll put within the square root.
Square.
So we'll get square root of x squared minus 4. So we get back capital F of x. So that means both are same things, correct?
Mhm.
So this is just to show you that we could actually break a function into smaller pieces and then connect them as shown here. It becomes much simpler for us to understand them and work on them. Is that clear?
Yeah.
Can you please answer question number 1A?
Write domain and range of the function f of x as defined above.
Yes. So what is the domain and range of capital F of x? Can you tell me?
So is it x has to be greater than or equal to 0 or no?
Okay. So basically the domain will depend on the domain of G, right? It
0.
cannot be more than that. Now domain of G, since it is a parabola, is all real numbers. However, G is defined as x squared minus 4. So for some values, it is going to give me a negative value. Since f is square root, we cannot take the negative values, correct? So we have to eliminate those negative values from the domain of G. So what are we left with? We need to have x squared minus 4 to be greater than equal to 0, right?
Mhm.
And therefore, the value of x can only be greater than equal to absolute value of 2, right? So
2.
it could be
Yeah.
greater than 2 or it could be less than equal to minus 2, right? So
Yeah.
it is greater than equal to absolute value of 2, we could say, or we say greater than equal to 2 or less than equal to 2, right? So that
Yeah.
becomes the domain of this particular function. Now, what is the range of the function now?
Is it that y has to be greater than or equal to 0?
Correct, because square root u is the final function, right? Output.
Mhm.
So whatever you put input, you cannot get a negative value. For 0, you'll get 0. So it is 0 or greater than 0. Clear?
Yeah.
Question number 1B. Can you answer this one, please?
Evaluate u and f of minus 3 if
Correct.
it exists.
Yes. So how will you work on this?
So you just sub in, so the minus 3,
Yeah.
you would put it into g of x, and
Correct.
then that value you put into f of x.
That is correct. So you start from inside out. So substitute x, you have f of g of x. Where do you see the x? Right inside. So that x should be replaced by minus 3. So you have to calculate what is g of minus 3. So when you substitute g of minus 3, you will get minus 3 squared is 9. 9 minus 4 is 5. So you'll get 5 as a result, right? So you get 5 as your result, which is the output, which acts as an input for f of u. So square root 5 is going to be your output. Clear?
Yeah.
Right. So let's move on and now understand what is the concept of chain rule. So you have understood what is a composite function, how to find its domain and range. That's very critical. Many times a part of the question will be to find domain and range of the composite function. Okay. And then evaluate function for some values. And next question comes based on calculus. Okay. Especially in GCSE, that is how they break it up. Okay. Now, chain rule, as we have said, is kind of a function of a function. That letter O, the small o which you see, is an operator for the composition of functions. F is composed of G, that is what. So that is what we say. So f of g of x, that is the another way of reading it. And g of x is the inside function. F of g of x, f is the outside function, right? Now to explain you this particular chain rule, I've taken a very simple concept. We began with gradient, right? We said gradient is a very common thing, and we'll now onwards call gradient as a derivative, correct?
Yeah.
We know derivative is gradient, which is rate of change. So if we consider derivative as rate of change, then what is du dx? Du dx is rate of change of u with respect to x, correct? dy du is rate of change of y with respect to u, and dy dx is the rate of change of y with respect to x, right? So they are kind of related. Now, think about a composite function. Like if we have something du dx, we're saying we are increasing the rate of change of u is, let us say, 2. Okay? And that 2 is the input to y, right? And we say now the rate of change is 3. So 2 gets multiplied by 3 and you get 6 as your result.
Yeah.
So that could be kind of your understanding of the chain rule. So if we want to find dy dx, the net result, since function of function is a function of gx, we need to differentiate with respect to the ultimate independent variable, which is x in this particular case, right?
Yeah.
So dy dx can be written as dy du times du dx. Does it make sense to you?
Oh, right. Yeah.
It's kind of a chain they are connected with, right? You can actually think like this. If I cancel this away, I'm left with what? Dy dx. Is that correct?
Oh, yeah.
So now this chain can be built. In g of x, I could have h of x and then so on. So I could have a long chain, right? So that is how it is. And in different conventions, we could also write this as derivative of the whole thing, outside function, times derivative of inside function, g dash x. That is du dx. Is that correct?
Yeah.
Du dx, u is g of x. So du dx is the derivative of inside function, correct? So that is how we will refer the chain rule to you, okay? So that is only possible if both are differentiable. That is, f dash x and g prime x exist, right?
Right.
Now, if I ask you to write a formula for the derivative of f of g of h of x, how will you write?
So would you do the derivative of... Oh, wait, can we work backwards?
Yeah, we can go straight. We can just add to this list uv, right? We will call v as h of x, right?
Okay.
And we can multiply by dv, right? as we do it, right?
Yeah.
So we could do that. So we will just extend dv du. Is that correct?
Yeah.
So once we do that, we get a change. So we'll define another variable v for victory, as h of x. So now we want dh dv, right? Do you understand?
All right.
dvdx,
Yeah.
dvdx, correct? So that is how we are going to connect, okay? So we'll have dy du, du dv, and we have dv dx.
Yeah.
This will change to v, and then we'll have dv dx. Is that correct? So write down in your notes and answer this question, okay?
Okay.
Next, we'll talk about now application of the chain rule. We have already seen how do we combine chain rule with the power rule. So
Mm-hmm.
this example is exactly based on that. So you have y equals to x squared minus 3x plus 5 to the power of pi. You need to find dy dx. So what you can do? You can apply the power rule. So it becomes pi times the whole thing, right? That is the first part.
Yeah.
Times the derivative of inside, which is x squared minus 3x plus 5. And you get your result. Is that clear to you?
Yeah.
So these are the steps to follow. Once again, we'll define u as your inside function, x squared minus 3x plus 5. Then find the derivative of u with respect to x. Those are the variables. You get 2x minus 3, correct? Now, since I wrote the inside function as u, I can now write y as u to the power of pi, correct?
Mm.
So dy du is pi times u to the power of pi minus 1. Pi is a number, right? Maybe irrational.
Mm.
Pi minus 1. Now replace u with function x. So you get dy du, and you also get du dx, both in terms of x. Is that clear to you?
Yeah.
Now you can apply the chain rule. You are interested in finding dy dx, which is basically product of dy du and du dx. Multiply them and simplify to get the result. Is that clear to you?
Yeah.
Okay. Sometimes we can just extend this question and say, find the derivative of this function when x is equal to 1, right? In that case, substitute 1 here and get your answer. Is that correct?
Makes sense. Yeah.
Perfect. So what basically we have done here is we have combined the power rule with the chain rule. So now, if you look into a function which is u to the power of n, right? We know that u is a function of x, so it will be n times u to the power of n minus 1 times the derivative of u with respect to x. Do you see that?
Yeah.
So you could write the derivative of some other function, let's say time, based on time, right? In based on something else, right? So rate of change of height with time, or rate of change of volume, right? So many
Yeah.
applications will involve so many other parameters, and we can actually use chain rule to answer those particular questions. Okay?
Mm-hmm.
Let's take example number 2 now, which is find dy dx at the indicated value of x. So this time we'll give you the value of x, okay? And you need to find the derivative. We have already written two functions separately. We are saying y is equal to 2u cube minus 2u square, and u is equal to x plus 1 over square root x. We are interested in finding the derivative dy dx at x equals to 1. Okay?
Mm-hmm.
How will you go about solving such a question? Tell me.
So I'll just pick one of the equations. So y equals x, add 1 over root x, and find the derivative of that,
Yes.
which would be the du over dx.
Okay.
So x derivative would just be 1, and then 1 over, so I'll put that into like index form. So
Yes.
it'll be 1 times x to the minus a half.
And then you will write this answer. Correct.
Yeah.
It is always better to convert it into the index form. You could write square 1 over square root x as x to the power of minus half. And when you do minus half minus 1, you get minus 3 over 2, right? And
Yeah.
you get this particular result for du dx. Correct.
And then I would sub the 1, because it says x equals to 1, into the derivative, and we get half.
Correct.
Then you take the next equation, which is y equals 2u cubed plus 3u squared.
Yes.
And I'll find the derivative of that,
Yes.
which is dy over du. So it will be 6, so 3 times 2 is 6, u squared, 3 minus 1, plus 6u, because you do 3 times 2 is 6, and then it would just be u to the 1. So then you sub, so we've been given what the formula for u is.
Yes.
So that's x plus 1 over root x, and now we want to find what x is. So we know x equals 1, so you just sub the 1 in,
Yes.
and we get the value of u as 2.
Correct.
Then you sub the 2 into the derivative, which we just found. So 6, 2 squared plus 6 times 2, and you get 36.
Yes.
So to find dy over dx, we learned the formula, which was you multiply du over dx by dy over du, and 36 times a half is 18.
You're right. Now, whenever you're given such a question, especially when you need to find the derivative at the given value of x, you would actually perform this step right in the beginning. That is my suggestion. So what I'm trying to say here is, you know what x is, but you don't know what u is, correct?
Yeah.
But ultimately, you are interested in both the values. So I'll suggest that when you're given this question, do this operation first.
Okay.
So you know x is 1 and u is 2. Then you start your derivatives with either of those functions, right?
Mm-hmm.
And find the derivative at x equals to 1 or u equals to whatever the u value is for x equals to 1, and then continue. Is it okay?
Okay. Yeah.
That is preferred. But this is also correct. Now, example number 3 for you is this slightly tricky. Instead of giving you the functions explicitly, we are saying y is a function of u, f of u, right? And u is a function of g, g of x. Express dy dx in terms of dy du, right? We don't want exact answer, right?
All right.
In terms of dy dx. We want dy dx in terms of dy du. Is that correct?
Yeah.
So that is the question. And see, we have not defined the gx function. Is that correct?
Yeah.
Right. So that is why in terms of dy du, where u is equal to square root of whatever. So that is your question now. So slightly different question, since in the end result, you will get dy du, since we did not give you that particular function. Does it make sense?
Yeah.
So u is given to us the whole function, right? Don't treat this now as a composite function. It is a composite function, of course, but there is something more than this also. Is that clear?
All right.
Okay.
Mm-hmm.
So we are saying u is square root of 11 minus x squared, which, as you said earlier, better to write in exponent form to the power of half, and then du dx will be half times this to the power of minus 1, which give you minus half. So I have written in denominator, correct?
Mm-hmm.
Times du dx of inside function, we applied the chain rule. So power rule and chain rule will be applied. Du dx of inside function, which is minus 2x, right? Minus 2x. So 2 and 2 cancel, you are left with minus x over the denominator of square root 11 minus x squared. So this is du dx. When you apply the chain rule to find dy dx, we know it is dy du times du dx. We only know what du dx is, correct?
Mm-hmm.
We don't know what dy du is, so that remains. And therefore, that is how it gets connected. Do you see that?
Oh, so you just leave it like that?
Yes.
Oh,
So
nice
that
and
is a
easy.
part of your answer. Do you see that? It's tricky.
Yeah.
Because sometimes you think, is something left? Is the question incomplete? And all these things? No. The question
Yeah,
is
it looks
complete.
incomplete.
Yes. Yes. It's kind of tricky, okay? So this is a real examination type question. But now we have example number 4 for you. Now in example number 4, can you read the question, please?
If f of 3 equals 4 and f prime 3 equals minus 1, f prime 6 equals 5, g of 3 equals 6, and derivative of g equals 3.
Yes.
No, derivative of
G,
G,
yeah, G prime 3 is better to read. Yeah, that's
yeah.
correct.
G prime 3 is 2.
Yes,
So determine f of g derivative of 3.
correct. And part B is this. Can you
Yeah.
explain me what you need to find in part A, please?
So part A, so would that be using the chain rule?
Yes.
Because it's got the operation
Operation
of,
complete.
yeah.
And what is this?
Part B, it's the product rule, which we did ages ago. So
Yeah.
that's where you do,
So that
yeah.
is important at this stage to understand and differentiate how we write them, correct? So they are
Yeah.
two different things. So, so what we have here is a chain rule. Okay. So what we have here is chain rule and also power rule, correct? So these are two different rules. Apply the relevant formulas and get your answer, correct? So this question has been answered using the formula, right? And that is the
Yeah.
nomenclature. So f of g derivative is, you'll take the derivative of f for the whole function and multiply by the derivative of inside function. That is the concept, correct?
Yeah.
Since we want this for x equals to 3, we evaluate the values, substitute x with 3, correct? So for
Mm-hmm.
the inside function g of 3, it is already given to us that g of 3 is 6. So I replace that with 6. Perfect?
Mm-hmm.
And f prime of 6 is 5. And so we replace that with 5. That is
All right.
these values. Clear?
Yeah.
On the other side, g prime of 3 is given to us as 2. So we replace that by 2, multiplying, we get 10 as our result. Perfect?
Yeah.
That is how it should be solved. When you apply the product rule, we know that it is the derivative of the first function times the second, then derivative of the second function times the first. Replace x with 3 and substitute the relevant values to get your answer. The answer in this case comes out to 2. Clear?
Yeah.
Perfect. The next question here is example 5. Very similar but different. Now that is the variety of questions which you can actually get in your test, okay?
All right.
Y equals to f of 3x to the power of 4. Normally we say y is a function of g of x. Now we have given g of x as 3x to the power of 4. And we are saying that the derivative of f at 3 is minus 5. You need to determine dy dx at x equals to 1. Right? This is the question for you. So,
Yeah.
strictly speaking, it is kind of a composite rule. We already have a function inside a function, right? So
Yeah.
we have derivative dy dx equals to derivative of 3x to the power of 4 times the derivative of inside function, right?
Oh, yeah.
Right. So derivative of inside function is 12x cubed. 4 times 3 is 12. 4 minus 1 is 3. So 4 12x cubed. So now you get derivative of the function 3x to the power of 4 times 12x cubed. You can substitute x equals to 1, and once you do that, at x equals to 1, this becomes f dash of 3, correct?
Yeah.
So this is x equals to 1, and that becomes 12. So you just multiply 12 by f dash of 3. The value of f dash of 3 is given to you, and you get your answer. Perfect.
Makes sense. Yeah.
In my example, I've only given you the value of f prime 3. In the test papers, they could give you value of f prime 1 also. So don't get confused. You should know which
Oh,
one to pick, okay?
oh, okay.
It's kind of very important to understand what exactly to pick from here and then get the right answer. So it could be tricky. Here is example 6, which is almost the last example. What we have done this time is made a function very complicated. We are
All
saying
right.
if y is equal to square root of x plus square root of x squared plus 2x plus 1, determine dy dx, right? So we
Mm-hmm.
have function inside function inside function. You understand? So you
Yeah.
can say this is h, this is g, and that is f. You see that?
All right. Yeah.
So when you have so many functions involved, uh, we would prefer to write them as UVW, something like this, right? And then
Mm.
do. But what I've done here is I worked with the concept that we are doing derivative of outside function. So the big thing outside function is the square root function, right?
Yeah.
So that derivative is half times the whole thing to the power of minus half, so it comes in the denominator. So everything comes in the denominator. Is that clear to you?
Yeah.
Times the derivative of inside function, and now for the big function, that is your inside function. Is that clear?
Yeah.
Then we again apply the same chain rule at this stage. Derivative of x is 1, and derivative of the square root term is 1 over 2 square root of the inside function. Multiply that with derivative of inside function. So continue in rule. And
All right.
this is 2x plus 2. Now you have actually found the derivative. You need to simplify the expression, and this is good enough to write as your final answer. Is that clear?
Mm-hmm.
So that is application of chain rule 3 times, I mean, and this is goes with your question number 1 to whatever we did earlier.
Yeah. Yeah.
Now, here are your practice questions. So I have 3 questions for you, Amy. You have to answer them at today or tomorrow. Submit the results, but we can discuss the solution now. So, could you please read the questions, and as you read, can you suggest me how are you going to answer these questions so that if there's a difficulty, I can address it now.
Okay. Apply chain rule to find derivative of the following functions. So f of x equals 4x cubed plus 2x squared minus 5 to the power of 3/4.
Yes.
So I can just use the chain rule. But
along with power rule. Perfect.
Could you use the power rule?
Yes, power rule.
No.
Extended power rule is chain rule with power rule. You're right.
Oh, I didn't know that.
3/4 of the whole thing to the power of 3/4 minus 1 times
the
derivative
derivative.
of highlighted area. Is that clear to you?
Yeah.
So it is the same rule, chain rule extended, which is, I mean, power rule extended, which is power rule combined with the chain, right?
Oh, okay. Then question 1b. So g of x equals square root of x plus square root x squared plus x.
Yes.
So that's similar to like the question 6 that you just showed me, isn't it?
That is right. Exactly similar to this. Follow this particular pattern. Practice. This is a sure short question in any test paper, right? Definitely. Okay.
Okay.
Next one, please.
Question 1c. F of x equals 2x plus 3 over x plus 1 whole thing to the power of 5.
Yes.
Again, I would use the similar to the question 1, so the power rule with the chain rule, the extended. And
so
then
inside function is the quotient rule, so you'll apply the quotient rule there. That is correct. Next one.
Question 1d. Y equals x plus cube root of 2x plus x squared to the power of 10. So again, I would use the power rule of bringing the 10 in front,
Okay.
but to get rid of finding the derivative of the cube root, I'll just put that into exponent form to the third, and then similar to that one.
Yeah, so basically you'll apply the power rule. It is actually similar to 1b, right?
All right.
So and then you'll continue to apply the chain rule twice again here to get your result. Perfect?
Yeah.
That should be easy. Question number 2, please.
2. So find ds dt where t equals 4 if s equals v plus 100 over v and b equals 5t minus t square 2 square root t.
Yes.
Yeah. So I'll choose one of the functions. So let's pick v equals 5t minus 2 square root t. Find the derivative of that. Sub t is 4 into that.
Correct.
Then use the s function,
Yes.
but we need to find v. Oh yes, you said do that first. So
Do
to
that
find,
first. Good job.
yeah.
I was waiting for that. Rest is easy. You understand? Yes.
Yeah.
Do it first. See, it is
That's,
important to go in a flow rather than going back and forth. Do you understand?
yeah,
So
that's true.
when we are given only t equals to 4, what is s?
You
Okay,
sub it.
let's put t equals to 4, find v first, right? Let's put
Yeah,
v and get s. At least at t equals to 4, we know all the three.
yeah,
The extended question could be asking for many different things. Like it is a actual real problem where we have displacement function, velocity function, and time. So we could actually mix it up with different situations and say, well, that is the speed at which the car is going. It applies the brakes, and this is what happens, right? After time
yeah.
t, find the displacement or the braking distance or stopping distance and all those things, correct?
Hmm.
Could be that kind of a word problem. We are just putting it very simple here. However, this is a part of a word problem, correct?
All right.
How you have to see. So when you have a question and a word problem, you get all your equations on the side and then get all the initial values or the values of interest on the other side.
That
So
makes sense. Yeah.
then you start working with part A, B, C, D, and so on. That becomes examination style question. Do you understand? So
Yeah.
in just a simple line, what I'm giving you is a part of a very complicated question, correct?
All right. Okay.
But this could be helpful. Now, question number 3, please.
So if f of 5 equals 4, f prime 5 equals minus 1, f prime 3 equals 4, and g of 5 equals 3, and g prime 5 equals 2, determine
We are
f
all,
of
I missed this value. I added this value later on. G of 3 is
g of 3 is equals 6 as well.
right.
F of, so part A is f of g whole thing prime to 3.
So derivative of the composite function f of g. You could say
Yeah,
like this: derivative of f of g, right?
derivative of f of
F of
g.
g at x equals to 3. Okay.
Oh, okay.
Yeah.
That's a good way of saying it.
Mm.
And then part B is derivative of f of
Product
fg,
of product of fg. So it's a
product of fg,
at
where
3.
at x equals to 3.
Correct. So that is another question for you, which you need to do, and you clearly understand that the first part is asking for what,
Chain rule,
and the second part
product rule.
clear. So that should not be very difficult. How do you find today's exercise?
Really good. That was quite straightforward.
You
Yeah.
have understood everything?
Yeah. It's just
Okay.
using the formulas and like you said, whatever's given in the question, do that part first.
Correct.
And then don't start the question until you've got all the information at the top, because like you said, it's like part of really complicated things.
Yeah.
So you rather get those things straightened out before you start the question. So
That is so
that's good.
true. Can you summarize in short what we did today and how it can help you?
Yeah, so we learned about the chain rule and the formula. So there and composite functions. So f of g of x, things like that. So where you do g of x, the inside function first, then you put that into f of x, which is the outside function. Chain rule being dy over dx equals, you could use, we chose u, but it could be anything. So dy
Any-
over du
Yeah.
times du over dx. Then using the chain rule, there's also the extended one where you use the power rule, which is, yeah, that's also really helpful. Combination of the two. And I think that's it.
That's it. Yeah.
Also the quotient rule you can use.
Correct. And with this, actually, we have learned how actually to apply all the rules in different circumstances. The
Yeah.
only thing which we also understand now here is that there could be different variables, right? We are doing single variable calculus. However, we could have single variables dependent on many other things in the same equation.
Yeah.
So the step is to work with more than one variable, and especially with equations where we cannot explicitly write an equation in terms of one thing. Like
All right.
normally we
Yeah.
write y equals to something, y equals to something, y equals to something, and we find dy dx. Or we could have an equation which is like xy plus xy squared plus y squared x. It may be difficult, very difficult for us to find out what y is. So in
Yeah.
this case, what we do is implicit differentiation. That is the next step. We'll learn that. So I'd like you to practice some questions on chain rule. And
Yeah.
implicit differentiation will again, it is extended chain rule, but with a different variable. Instead of UVW, we may use some other variables, but it is still an
Okay.
extension of the chain rule itself. And
Mhm.
then once we do implicit differentiation, we'll do rate of change and optimization applications. Okay, so that's going to be extremely useful.
No big words.
Very good. Yeah. And meanwhile, now start your work on your book, and
Okay.
you should actually sail through it, or wherever you have little problems, or like even if you have to think a bit, share with me, right? Because
Okay.
I would like to understand why was there a need to think, right? So when you know it,
Okay.
when we walk, do we think? We don't, right? We just walk through.
That's true.
So
Yes.
that is how it should be when you do calculus now with me, right? So just walk through. And if you have to think, you have to let me know where were you thinking, right? So there was
Okay.
a traffic light, like what happened? Come on, or an accident somewhere. So let me know, and then we'll see how to address those blocks. Is that clear?
That's really
By the
clear.
time we end up calculus, you should actually walk through it. No thinking
All
required.
right.
Leave thinking for others to do. Like, how come I'm just giving all the answers?
Yeah. Just
Okay,
walk through.
just walk through it, right?
Right.
That was great, and I hope things will be fine. Just keep sharing as you have been doing.
Will
And
do. Thank you so much, sir. I really appreciate it.
my pleasure.
Have a good rest of your day.
Same to you. Thank you.
Bye, sir.